Hello everyone, welcome to Practical GCP. So today I want to cover a topic on how you could use a fully managed solution called BigQuery Transfer Service to optimize a file-based change data capturing solution that you might actually come across. And the reason I want to talk about this in the specific context of file-based CDC is that it's not always the easiest to do everything yourself, right? Or deploy your own solutions from scratch. So this is where sometimes the fully managed service such as BigQuery Transfer Service can be very handy. So let's start with our kind of contents agenda today. So we're going to talk about just very briefly to cover what is a file-based CDC solution, just in case you've not come across these ones before, and why BigQuery is kind of relevant here. And then we'll compare, there's two ways you can actually use BigQuery. One is kind of using federated queries, or you can actually use native queries. And I'll explain why this is actually quite an important distinction that you might want to pay attention to. And the key point in here is to really kind of highlight the low maintenance kind of feature of the BigQuery Transfer Service. And then we'll talk about exactly how this can help optimizing the CDC solution in this particular context. Of course, as usual, show a demo and then we'll do a summary at the very end. Okay, so what is a file-based change data capturing solution? I'm not going to go into too much details, but it's important to understand what exactly is file-based CDC, right? So you may have, in this case, a transactional database where you have a lot of this kind of data coming through based on a lot of changes being made. These are additions to the tables, changes to the tables, or deletion to the tables, right? Those are turned into the form of events, and then you have various kind of solutions. There are actually quite a lot in the market that you can use them to track those changes. The file-based CDC solution is those ones that don't actually go into a database as their target. So the way this typically works is you have some sort of pipeline that buffers typically between 10 to 15 minutes worth of data, right? Then it will write them into a single file, such as in a format of Avro, Parquet, or ORC. So those are the kind of formats you probably will see like in your situations. And that's kind of file-based, right? It's actually not going to a database. So why is BigQuery relevant then in this context? If you look at this diagram, the first part is identical, but when you get to the point of the file-based solution, usually the reason this happens is because you have other solutions, such as you may have a Hadoop ecosystem that kind of you currently migrated, have a deployment or lift and shift deployment from your legacy or on-prem solutions onto, in this case, let's say Google Cloud, right? So, and the storage engine behind Hadoop, especially when let's say you use Hive to process data, and all of that file is stored in HDFS, which is kind of mapped into the Google Cloud storage layer behind the scenes, and those are stored as ORC files, right? So you may have other solutions, let's say if you use Databricks, those also access files directly from those buckets. But your end state, right? Your end state architecture is you want everything to be processed on BigQuery natively, or in a way processed on BigQuery. So this is why BigQuery is relevant here, because in order to transition right into your, whether you can call it a legacy stack or any other solutions, that the bucket in here with the file landed in here, those is actually the key part you want to focus on when you transition from the older solutions or other solutions into your end state. So this is where it gets interesting. You have two ways to access data in those files, right? So one way is you just access those files as federated compute. So what that means is you basically mount, let's say, a folder right here, a bunch of Parquet files in a folder matching certain URI, right, into your BigQuery federated tables, and then you actually just run those queries. So these will use the process files directly, right? Because the files have not been loaded yet. They will process the files directly and then use the BigQuery compute to process your data, right? But you've not moved your data yet. The other way is as you all know, if you're already using BigQuery, is you typically have to load the data into BigQuery before you can get all of the benefit or processing those data natively, right? Those are the two ways. There's pros and cons, right? So with the BigQuery federated queries, obviously you don't need to load the data at all. So right, that data stays where they were, right? The issues with that is less efficient in most cases because it's not actually using the all of the native engine that you actually have in BigQuery. And also there's no easy way to partition the data very often, which leads to a higher cost, right? So those are the typical downside you have with those things. And some of these, let's say if it's very hard to partition data, is not exactly easy to use, then some of this could become showstoppers, right? Or it becomes extremely inconvenient to work with. Obviously, the other way is you can load data into BigQuery, right? In those cases, because this is now a native database table, is more efficient, and there are no limitations either. So, such as if you want to use continuous queries, and then this one would support it, but however, those won't be supported in federated queries, right? So you can actually make the most of the native engine, but loading data into the BigQuery tables isn't always maintenance free, right? So, and this is why we are talking about, in this context, why the BigQuery transfer service can be an ideal solution to reduce a lot of the burdens you have to work with. Again, most of these still is the same. You still have the same files. These files are going to the GCS bucket. Your existing solution will continue to work. But when it comes to the BigQuery part, right? So you actually split the solution into two parts. One is you do a one-off load of whole historical data. Let's say you have, I don't know, like 1,000 tables, right? You want all of these to be natively processed within BigQuery. You do a one-off load, right, to all of those Parquet files, just using BigQuery load or into BigQuery. So those never change, right? They just stay in the table. They're historical data. They don't change. The interesting part is where you can use the BigQuery Transfer Service on every 15 minutes, for example, right? Every 15 minutes, you can track the new files and then do a delta load on all of the additional files, right? And then it'll put those into the BigQuery table. So this is very nice because, first of all, the data transfer service is a fully managed solution, which means I'll show you in a minute how easy it is to set it up. It's really not that much work at all, because you don't have to manage it yourself, right? You just kind of set up these jobs and then to monitor a pattern or a directory on the GCS bucket, and then it does this thing, right? This is kind of a based on an append-only solution. So whatever changes happens, right? These CDC solutions, it will keep kind of appending those events as new files, as Parquet files in this case. And then you just basically append those as rows into your BigQuery table. Once these are done, right? If you think about it, you have a kind of like 15 minutes latency. If you add this, it's probably like 15 to 30 minutes latency solution that it will allow you to optimize typically two workload. One is if you have users, you can easily, because now your data is fully partitioned, right? And then you can actually optimize the data access in this particular way for all your users. Also, if you want to do delta tracking, which is one of the most things you do with partitioned data tracking, right? In those cases, you can easily track the data using the partitions. Then it saves you cost, improve efficiency, right? So plus, as I mentioned previously, you can use all of the native capabilities of BigQuery native tables, such as continuous queries, when this thing becomes GA in the future. So I think that's there's quite a few benefits, and that's why, in my view, this would be a lot better solution rather than you just trying to kind of hack it around with the file system using external tables. You can get started with that, but when you started kind of getting efficiency, you want to use this as your strategic solution without really changing your CDC pipelines. This can be very handy. Okay, let's do a quick demo on this, right? So what I've done is, if you look at the under the BigQuery section, you have data transfers. In data transfer, you can create a transfer. You can see I've created one already in here, which is the using the source as Google Cloud Storage, GCS, right? And then it has a target of the BigQuery examples dataset, right? So if I show you what it is like so I already did some runs. I'll explain like what I was testing kind of before. But if you look at the configuration, there's a few important things to mention. It always runs as a service account. So this is not running against you as a user, which is very important because this runs in the background without actually attaching to any individuals, right? So you can see here, I've actually created the destination table, which is customer, and I've got the URI here for the storage. This is very interesting, right? So you can actually use wildcard. So this matches a pattern. So any files matching customer underscore data underscore star, which could be anything in between. So those are usually the files generated as 0, 1, 2, 3, 4, 5, 6. So all timestamps, right? So those are the one typically gets generated as a suffix in those CDC solutions. And then you have only pick up the Parquet files, so it doesn't pick up any other random stuff. The write preference in here is append only because we don't really care about anything else. There's another option, but I think it's going to have the same outcome if you're using something like Parquet, which you don't really modify the files. And then you basically have the write preference as append. So all of your BigQuery tables in this case is going to keep having new partitions added with new data added, right? So the rest, there's not much to say about it. So in this case, you can see that in run history, I've been testing this quite a bit yesterday. So the way it works is you can obviously schedule this, but what I was doing is I was trying to see if I just run it manually every time on demand, what does it actually do? It does use the term backfill when you do this stuff, but it doesn't actually do that, right? So it is always, it doesn't matter whether you try to run it manually with just a trigger to, for whatever reason, if you prefer, using a manual trigger. It could be your scheduler somewhere else, right? Or you just use the native scheduler here, and that is just going to manage it. You can set it to every 15 minutes, which is the minimum you can set. You can't set it any lower than that for good reasons, such as if you set it too low, it will overwhelm the quotas because it uses a BigQuery load job behind the scenes. So if you look at some of these jobs, you can see I've actually got a file generator for Parquet behind the scenes to generate random customer data, the fake ones. I'll show you in a bit in the bucket. But you can see the ones I've been running before because I've been generating files behind the scenes. So this pick up one file, this pick up one file, and this one picked up 4 files, this one picked up 5 files, right? And so on. And some of the other ones I generated smaller ones. You can see here it's picked up 26 files, and here it picked up 23 files. So the solution basically always pick up the new ones you generated based on I think every time it runs, it just kind of sets a timestamp, and everything generates after that. It will pick it up in the next run. So it has a state behind the scenes. So what I'm going to do is right now I have no files, right? This is the GCS bucket I've created. What I've done is, what I want to show you is, let me see. So the BigQuery table is the customer table. Currently the schema looks like this, and it has no data, right? So I have a clean state. What I'm going to do is I will go back to my IDE. You can see this is just a simple script to generate 10,000 rows. I've actually tried with a lot bigger volume, let's say 100,000 files per 100,000 rows per file. It doesn't really make a difference because this is a fully managed solution using BigQuery load behind the scenes. But here I'm generating IDs, the general fields of the customer, all of this stuff, right? I've turned that into a Panda data frames, and I use Apache Arrow to save it as a Parquet files in here to write it into GCS, right? So I'm just going to run it, and in this case, you can see when I started running this thing, it will start generating files and writing it into the folder, right? If I go back to my GCS bucket, if I start refreshing, you can see now I've got these Parquet files coming through, right? So if I go back to the BigQuery Transfer Service and then just run the job, just as a one-time transfer, this is confusing. It's not a backfill. The first time you run it, kind of yes, but if you have more files generated, even you click this button, it won't actually go back from the beginning. So keep in mind, when you actually do this in for production use, you may not want to do this from the UI. I'm just doing this to show you exactly how it works. It's always easier to do this in the interface. There's SDKs, the Python SDKs available, right? So you can actually set all of this up programmatically yourself. Because let's say if you have 1,000 structures, right? So not tables in, let's say 1,000 structures, which represent 1,000 tables. Then you're going to have to set up 1,000 of those jobs, right? You don't want to do that manually. That's not going to be, very unreliable. Now you can see if I refresh this thing, so it should be kicking. Yeah, you've got a new one. So you can see here it's picked up 6 files, right? And then in here I've already generated now I have 22 files. Well, 23 starting from 0, right? So it just shows you, it just pick up the point at time on what it hasn't processed based on most likely created timestamp, right? And now if you look at BigQuery, if I refresh this, you've got the data in here, right? This table now is partitioned. You can see it's partitioned by the ingestion timestamp, which is whenever you actually land something, it will just partition it automatically based on when it's actually landed in there, which in my view is the most handy way to track this sort of the processes rather than creating your own one. You can have your own timestamp to track exactly when the events have happened if you actually have the luxury, but not every time you can generate your own timestamp, right? Based on what's in those original files. Now, if I look at the number of rows I've got in the table, so that's 60,000, right? So that's the reason, because it processed six files and I will have 10,000 each. So you can see it worked as expected. Now I think the job is probably finished, right? If I trigger another one, so I'll let that run in the background. I'll see if this is finished. So it's written 41 at the moment. So if I go back, and I can see how far it got to. So this time it picked up 35 files, right? So that's kind of the way it works. So it does all of these things for you. If you do this yourself, you can, but you're gonna have to do some tracking yourself, delta tracking, timestamp tracking. It's just code you have to maintain. Why do you want to do that if something like this can do it for you? Right, so if you look at BigQuery now, if I look at the data, so it's very efficient because it uses BigQuery load behind the scenes. So it's very scalable solution. You can load huge amount of data in there, right? It's no problem at all. So now you've got close to 500,000 records already, right? That's kind of the way it works. Yeah, I think there's not much point to show you anything else. It's just a really simple solution. You can easily deploy. If you just have a few things, you could use a UI, but I highly recommend you use the SDK to do this dynamically. So if something goes wrong, you can always recover it. Yeah. So let's go back, right? Let's sum this up. So BigQuery Transfer Service is a low maintenance solution, right? There's still something to do. If something goes wrong, you need to have a look at why it went wrong, if some schema issues or whatever. But it is a low maintenance solution, right? So there's not much you have to do about it. This solution is based on a one-off historical load and a BQ transfer delta load, which runs in this case every 50 minutes. And this would give you the ability to query all of your data in the BigQuery native tables or native workload. So this, as I mentioned, it has many benefits, including you don't really have any limitations, such as if you want to use continuous queries when it comes to GA, you can, right? So if you have any downstream, you want to track those changes to do other things, it is a very important feature. You don't want to lose these kind of things. It's good to think about this kind of stuff. If you use federated tables, yeah, you can do all this yourself. One, it makes it quite difficult to partition, and also it's not exactly using the native capabilities of BigQuery, so you're kind of losing other features. One of the key things is there is actually no impact to existing solutions, or you don't have to make any changes to the existing solutions, right? This is one of the key things. It really helps you to transition from your existing solution that you're trying to decommission, right, or getting rid of, into your new solutions. You can have dual run, right? You can have both running at the same time. your source of truth from your data lake, in this case, all of those Parquet raw files, is identical, right? Whether you use it directly or you load it, you're not actually manipulating any of this stuff. If you're using a managed solution, like a fully managed one like this one, you don't have any logic, so it's very unlikely to get things wrong as well, right? So there are some downsides though. It only has 15 minutes minimum schedule, so this means if you want better latency than 15 to 30 minutes, because you're gonna have those buffers from your source system CDC solution as well. You can't have that, right? So but to be honest, in most of the cases, this latency doesn't really matter too much from what I can see for most of the use cases. Keep in mind you've not actually redone the whole CDC solution. That is usually a huge investment. You have to really consider, rather than try to reuse what you already got with a little bit of a trade-offs. Then this gives you everything out of the box, right? You can just use it with this simple solution deploy. You can do this in less than a couple of days, right? So to get this solution live. But if you have to redo the whole CDC solution to have everything natively, sometimes these software you use may not even support the things such as schema evolution. So you could actually end up with a worse situation than where you're currently on. So yeah, the other thing is the whole storage transfer solution is scheduling based, right? So it's not based on a file drop trigger. So this means, as I mentioned, it's not just a 15 minutes schedule, but it also it runs every 15 minutes, right? It doesn't actually know the file's been dropped in there 15 minutes ago or 1 minute after the last checkpoint. So that means it by default give you a higher latency. Again, a little bit of a downside, but I think the benefits, especially that because you don't really have to change your existing solutions, so you just reuse what's already in there for everything to work natively in BigQuery. I think that's a huge win in there, right? So yeah, that's everything I want to cover today. It's quite a simple topic, but I think in my view, it could be quite effective, especially if you're in a situation that you're migrating from the old solution, you already have your old CDC solution, or even not a CDC solution, right? A batch solution that you used to load data into in Parquet files or ORC files, whatever you used to do, right? And then you can actually use this kind of solution to bridge that gap and optimize the workload in your new world, in your end state. Yeah, thank you very much for listening. I'll see you next time.
Go out!